So when we're designing a build, so say we were given the objective of designing a building, the first thing we would do is that what are the parameters that say lead to cost, okay? And cost is also a direct function of resource. So typically speaking, a building weighs about anywhere between 1,000 to 1,500 kgs per square meter. So if one were to look at the fact that a person in a commercial building occupies about 10 square meters and maybe 30 square meters in a residential building. So in an office building, you need roughly about 15 tons of material to support each person, 15,000 kgs. Now those 15,000 kgs are coming from various parts of the world. There's cement, steel, wood, glass, etc. what have you. Now that's an incredibly inefficient method of working, because 15,000 kgs of material to provide shelter to a person whose average weight is 60-65 kgs. And I can't think of anything more wasteful than that. So when we are designing, we're saying, okay, where does all that material come from? What is really that material doing? Now the cement and steel is going into that building to prevent that building from collapsing and supporting the people in that building and preventing you from falling through the floor. And so what are the forces of gravity, okay, and the forces of earthquake and the forces of wind that are causing that to happen, which is making that structure heavier and bulkier? And then we begin to think from first principles, what is it that could counteract that? So if you're in a high earthquake zone, we'd probably work with a central core building with a symmetrical floor plate. We do maybe completely something diametrically opposite if we were in a high wind zone with low seismic forces. So then we'd go a little bit more aerodynamic. Again, looking at your local environment, macro and micro, we can begin to optimize. So we can successfully scale off costs from the structure. We can scale off by doing envelope optimization, by looking at passive design, close to 50 to 60, maybe sometimes even 70% of the air conditioning and artificial lighting that goes into a building, which obviously leads to a lesser cost of construction in a building. We can look at doing smart integrated facades that let the daylight in, keep the sun out, block the glare. And we can look at doing efficiency optimization by making the building itself far more efficient in the way it parks cars and the way it houses people. So we build lesser, so that we take away anything that is, let us say, a vestigial organ to that building by making the building itself efficient. And by putting all those things together, we come up with products that become more affordable or relatively more affordable.